feels like we're supposed to scroll back up here and ponder. Okay, so now at a fixed temperature, let's say 0 degrees C, fixed temperature, we're going to change pressure. So here we would have a high pressure. Well, we said it's pressure it's a low pressure, and then you would increase pressure, right, to get to a solid. So that phase, does it take time to get across that phase? So this part's funky. It has me pondering for a long time. Let's go up to here. So on this diagram, at a fixed temperature, a low pressure is a vapor, increase the pressure is a liquid, increase the pressure more is a solid. So that diagram then fits the inverse of pressure at the phase boundaries. But when we get into this section here, which is what we look at with this one, this is different. As we decrease the pressure, we go to a solid, which is counterintuitive to me. So down on this one, right, it would actually be the pressure has to decrease, so 1 over pressure is increasing, so it actually would go up instead of down. This would go up, so it'd be a different curve. The pondering whether we got the right diagram or whatever is that if we said the pressure part of that curve is related to energy, consciousness, and energy being on the y-axis where pressure was, then what changes the energy? What is this question mark? If we change molecules per cubic centimeter, we impact the pressure. What do we change in order to change the energy for that diagram? Alright, so I already drew this. Let's take a look. We're going to scroll up just so you know where I'm at here. Alright, so 100 degrees C in isotherm, constant 100 degrees C, and we're going to take a look at the pressure that goes across at 101 kilopascals, 100 degrees of C. Lower pressure, we're in a gas state, we get to pressure increases to 101 kilopascals. It's a boundary. It probably stays there for a bit until something changes, and then the pressure phase changes to water, and now our pressure can increase again. So let's go take a look at that other diagram I just made, and let's see what shows that. Right, so low pressure is a gas. The pressure increases till it gets to 101, and this is for 100 degrees C. It stays at that phase boundary until it gets to the next phase, and then the pressure can increase in a liquid form. But when we're at a constant pressure and we're varying the temperature and we put in heat, this is pressure is changing, but what are we doing to the system to make the pressure change? Are we putting in work? Are we like compressing a cylinder or putting in work to the system in order to affect the pressure change? I don't know what this one is. I don't know what that one is. So let's look at 0 degrees Celsius, low pressure. We're in a gas phase. Pressure increases, hits a boundary for a while, crosses into a solid, the ice. Pressure increases, we hit a boundary. pressure stays constant. Crossover, pressure increases into a water phase. So gas, flat, solid, flat, water. Let's go back down and create a diagram for that, see what that looks like. Probably not going to keep anyone safe for free any whales or anything. Let's have a look. So this is going to be at 0 degrees C. Pressure, we don't know what that is. 101 kilopascals. So down here we had gas. It hit a flat. And we got to group this. It hit a flat. Come on. I need room here. Alright. Get rid of that. I need a line. So it was gas, a flat. Then it was ice. And a flat. Okay, let's live. Alright, so when the liquid is up here, this was ice. So that's what we said. Low pressure was a gas. It got to a boundary. Something has to happen, and then it changes to an ice phase. It gets to another boundary. Something happens, and it changes to liquid phase, and the pressure can increase at 0 degrees C for water. I think we're at the end of this part of the rabbit hole. So this is our, at 0 degrees C, 101 kilopascals. No, let me check that. So 101 kilopascals is where it goes from ice to water. So this is what we said. At 0 degrees C, at a low pressure, we're in a gas state. Increase the pressure. We get to the boundary between gas and ice, and there's probably some period where pressure doesn't change, and then pressure will increase in the ice phase, and then there will be a boundary where pressure doesn't increase, and then you're in the liquid phase, and then pressure will increase again. So what does this mean? If I take like a piston, it's like 30 degrees outside now, freezing, put air in the piston, it's sealed, hook it up to a hydraulic pump, I start increasing the pressure in the gas mixture, in the water vapor is increasing. It gets to a point, I'm still applying force, hydraulic pressure, force onto the cylinder. There's a period where the pressure doesn't increase, but we have, at the end of that, it changes to ice. So now I have ice in the cylinder. So there's now ice in there, continually applying, hydraulic pressure up to 5,000 psi, whatever. So now the pressure in the cylinder is increasing in an ice phase. It gets to a boundary, still applying lots of physical force to the cylinder, no change in pressure, and then it goes from ice to liquid to water in the cylinder, and now the pressure in the cylinder is increasing. Wow, that's twisted. Whoa. I would have thought gas to liquid to ice. I wouldn't have thought it would have went to ice first. So maybe all that said, like, what is this thing down here? Is this like force or work? I don't know. But I think we're at the end of this tunnel in the rabbit hole. I don't know where else to go after this.